Hey everyone, welcome to the video for assignment 1 in my game developer assignment series. I'm really excited to do this and a little bit nervous. I obviously am the person who wrote the prompts as the producer, but I haven't fully thought out on how to solve any of the prompts. I tried to make this as realistic as possible. So yeah, since this is the first assignment, we might run into some bumps with the existing code base, and that's kind of the point of these assignments. In real life, you're just going to be working on an existing code base that tons of other programmers have worked on for possibly decades before you. So there's surely existing bugs. You're surely going to introduce bugs yourself that you'll find later. So yeah, it's just a process, but should be fun. So let's get started. Reading the email from the producer. Hey Andrew, nice work on setting up a basic level editor and enemy movement. Next, we'd like to add the option for the player to put down towers. These towers should throw axes at enemies as they approach. Here's a list of some specific requirements. For tower placement, only allow tower placement on the brick-looking tiles. No towers in the enemy's path. Towers should not be allowed to overlap each other. The player should see a preview of their placement with some indication of whether that placement is valid or not. Regarding the tower behavior, towers should throw axes at the nearest enemies. Bonus, we'd like the axes to spin as they fly through the air. Towers should face the enemy as they throw the axe. Remember that towers in this game are probably just going to be the people and not actual towers. So they actually do have some directionality to them. And then gameplay-wise, we'd like the player to start off with 10 gold and 10 lives, and the player should lose 1 life every time an enemy reaches the end of their path. When the player reaches 0 life, the game ends. Towers should cost the player 3 gold to purchase. Axes should deal 1 point of damage to the enemy and disappear once they're hit. Bonus, allow axes to persist once they hit the enemy, but keep them stuck in them. Sort of a little visual bonus there. Enemies should have 3 health and should disappear once their health reaches 0. When an axe hits an enemy, it should knock the enemy back in the direction of the hit. When an enemy dies, the player should gain 1 gold, and enemies should spawn faster over time. And if you have any questions, please reach out. And what you'll notice about this email from your producer is it's written in language that anybody can understand. It doesn't tell you how to implement any of these things. It's just talking about the gameplay, a little bit of the game feel, but it leaves it up to the developer to decide how they want to go about this. So, and that's kind of the fun part about being a developer is that you're really the master of your own domain. So what we want to do here and how we want to achieve it is up to us. And as long as we reach the end goal and the producers are happy, they'll have endless amounts of tasks to give us. So I just have the project open here, and I've synced to assignment 1 on the GitHub. If you're not familiar with how to get started, go back to my first video in this series. It'll have a little getting started section where it tells you how to clone the repository and make sure that you sync up to the correct assignment. Now, just running the game once in debug mode, I'm just sort of reminding myself of where I left off. So when you run the game, you can use WASD to move around. We probably don't need any of this anymore because this is not what the game is about. When you press T, we go into level editor mode, where we can use the mouse wheel to change between what kind of tiles we're putting down. Left click places the tiles, right click removes the tiles. S is for spawn, E is for end, and P is for path. So I'd like the enemies to spawn there, and I'd like them to path over here. When we click T to leave level editor mode, the game just immediately starts and the enemies are spawning and moving. And this is where we left off on our tutorial series. So we have the very bare bones for a game here, but there's currently no mechanics, which is why our producer is pushing on us to get some things added to the game. Additionally, we can do multiple paths and the enemies will sort of pick a path to go, which is very cool. Okay, now to start actually coding, I think the first thing that I would like to do is just start with the towers. So I'd like the player to be able to left click and they'll put down one of these little humans, and there'll be no axes involved. These little humanoids, these will be what I consider a tower. So let's click out of this. And I'm also familiarizing myself with this code base. For people that didn't follow along with the tutorial series, this will all be new to you. There's not a ton of code here, so it should be pretty manageable bite-sized chunks. If you're completely unfamiliar with it and it's a little overwhelming, you might just want to watch this first, me do the first assignment to watch me work with the code base, but do whatever works for you. So I think the first thing that I can do is almost just repurpose this player, which is an entity, to a list of towers, which will essentially be players, but you don't actually get to move them around. Sort of like this, how we did with the enemies. We have this vector of enemies. So I'm just gonna kind of jump right in and just start coding, and we'll see where we end up. So instead of a player, we're going to have a list of towers. Sure. And we don't really need an axe right now. I think how we ended up doing the enemy was that we set up one enemy, and then whenever we spawn them, we just use this enemy template and sort of copied over the entity. So we might want to do something similar with the tower, where we have a tower template, and we'll just set up one tower in code, and then whenever we create future towers, we can just use the tower template. So let's go over here. Yeah, of course. So now we have this enemy template, and we don't have a player anymore. Holy cow, what just happened there? Do I have insert on? I did have insert on. Okay, so we want a tower template. And actually, it's kind of funny. We added support for these dynamic objects, and originally I kind of thought like the player and the enemy would be dynamic, but now we're making a tower defense game. So the towers are actually just static. We don't really have to worry about them moving anywhere. And we don't have this axe anymore, so I can just get rid of that. And then towers. So let's see here. We have the player texture. I am going to rename this to tower texture, because in a tower defense game, you typically, misclicking my keyboard on repeat, you typically don't have a player. So I think most of this stuff is just sort of dated at this point. So we have a tower texture. Put that there. It's fine if it still says player.png. We can update the comment though. Load the tower texture. Load the tower texture. Create a sprite. And this is the kind of stuff that we don't need. Well, we can still do it, but we'll do it for the tower template. And then this will be the tower texture. And then right now we have our tower as in a circle with a radius of 80, but I believe that we ended up doing the enemies at a radius of 40. It was a little more manageable. The tiles themselves are 160 by 160. So since the producer asked us to not have the towers overlap, I think that we should start with a little bit of a smaller tower so that we can pack them in a little bit easier. So what I'm going to do is I'm going to change these both to the tower template, but I'm going to change the radius here to 40. And the towers have an entity to ignore, but we're not using axes anymore, so we don't need that. We don't need any of this axe stuff. Don't need this axe. Cool. Very nice. In our player velocity, kind of sad, but we don't have a player anymore, so they're not going to be moving anywhere. We don't have to worry about where we put the axe. Nope, don't need to worry about the axe anymore. This is all of our enemy code. When we're updating the physics, we don't need to push back the axe. We don't need to push back the player. But we do need to push back all of the towers. So I'll say for entity tower in towers, push back the tower. Now, I don't actually think, well, it may be possible for the enemies to hit the towers. We have it so the enemies don't hit aesthetic tiles right now. And if I just well, actually I can't run the game right now, so I'll show you in a second. When we're drawing the play mode, we want to draw all the enemies. We additionally want to draw all of the towers. Let's see if now we can play the play mode. So if you remember, I'm just going to set up a really basic level right now. So we'll start there, we'll end here, and here's our path. Right now, we don't let these guys hit aesthetic tiles, which means that if we put a blue tile in the middle here, it kind of like disrupts the whole flow of the game. Now, we should be able to color the path that the enemies travel on, pretty obviously. So I think that what I'll end up doing is probably just removing the aesthetic tiles from the physics simulation, because kind of how the name says, like, they're aesthetic. They should just look cool, and maybe they should tell the player what to expect there. For instance, like the trail that the enemies travel on maybe should look like a path, and where you put the towers should look like grass or dirt, but it shouldn't actually impact the gameplay directly. And I'm actually just going to make that change now. So in my update physics, when we go and iterate over all the aesthetic tiles, I'm just going to say, don't worry about that. Aesthetics are aesthetics. They don't impact gameplay at all. So now we can do a start here. We can do an end here with a path in between. And I will add some green tiles behind it, and now the enemies can just travel along the green path, and there's no harm, no foul there. And then what I was kind of saying before is that if you wanted to differentiate this, you could make it so the rest of the game is this brick texture, which is what our producer wanted us to be able to put the towers on, and then you could make the path green. And maybe this is a good time to say this, but don't worry that the path is green right now. You should really just address whatever the producer asked you to address, because the producer also knows that the path is green. They'll see that the path is green, and they'll request it to be changed. You don't have to worry about that. If something goes unmentioned for a long time, maybe you'd want to mention it. But at this stage in the project, I think everybody kind of understands that this is temporary. Okay. So that's really cool. We've already removed the player. We've kind of fixed the aesthetic problem. The next thing that we would like to do is be able to place towers. So what I'm kind of thinking right now is I'd like to see how we place tiles in our tile editor mode, and maybe do something similar for the towers themselves. So let's go see how we create tile. So this will be in the handle level editor input. We say, oh, that's if the left button is clicked. Okay, so maybe it's just in the draw level editor. Yeah, so in draw level editor, we get the mouse position, and then we set the position of a sprite to the mouse position. And then do we draw this tile option? We do draw that tile option. So what I'm thinking is that in our draw play, what we'll want to do is something very similar, where we get the mouse position, and then we'll set our tower templates position. Okay. And then we'll set our tower templates position. Come on, goofball. Tower template, and then we'll set the tower template position, and then as a last thing, we're gonna draw the tower template. Now, this will have one gameplay implication that we should be aware of, which is that while I am drawing the tower template and showing it, the tower template is not added in our physics update. So the tower template should not interfere with the actual enemies. There should be no collision on it. And additionally, it should only be drawn in play mode. And there it is. And it's a little bit bigger than I expected it to be. I thought this was supposed to be, oh, you know what it is? The size of our sprite and the physics are not tightly coupled. So the tower template scale needs to be changed to 5:5, Remember that the sprite originally is drawn as a 16 by 16. So you multiply that by 5, it'd be an 80 by 80. You put a circle in the center of that. The radius is 40. This sort of math comes up all the time in game development. You'll get very quick at it and thinking of it in your head. Okay, so let's go back in here. You'll see we have the little tower. If I go to level editor mode and I click start and put a path down, and then this tower should not interfere with this at all. Okay, and then the next thing I'd like to do is whenever I left click, I would like to see a tower just created directly at that position. So let's go over that. So this is where I wanted to see my create tile at position thing. So how I was doing that was I was saying if the left mouse button is pressed, then create a tile at position. And that does a lot of work. Right now, we don't have to do a ton of work. So what I'm going to do is just copy this. What I'm going to do is copy that. And then when I go to handle play input, I suppose the requested player movement stuff is all obsolete at this point. So it might just be best to remove it. It might be best. I'm just going to remove the requested player movement information because it's just cluttering our game at this point and we're not using it. We didn't know what kind of game we were going to make at the beginning, but now that we know we are going to make a tower defense game, we don't really care about the player movement. That's not what a tower defense game is all about. Okay, so in our handle play input, what we're going to do is say you have left clicked. We're not going to create a tile at position. Instead, we are going to create a tower at position, and we need this mouse position, and that can be grabbed here. So let's do that real quick. So we grab the tower position, and then we just need to add this function. So I believe these are all my level editor functions. And so what I'm going to do is just say, these are my play functions. And the first function I would like to add is a create tower at position function. Oops. And this shouldn't be too bad. So what we're going to do is we're going to create a new entity. And probably a better way to do this is, that's probably fine for now. We don't need to overcomplicate things. So we're going to create a new entity straight from our enemy template. We shouldn't actually even have to set the position to the mouse position because the tower template's position is going to be updated to the mouse's position all the time. And then we just push that back to the towers. So let's see what that does. And now when we click, we put down a tower. Very cool. But if we go back to the email for tower placement, there is a lot of requirements that we're not hitting right now, which is that towers should not be allowed to overlap with each other. They should only be put on the brick-looking tiles, and the player should see a preview of their placement. So what we need to say is we need to say, are we allowed to place a tower at this position? So what we'll say here is if can place tower at position, and we'll pass in a position, then we'll create the tower at the position, else we'll just do nothing. And this is a good way, or this is at least how I like to code, where I sort of write what I want the end code to look like before I write any of the functions. So how I want this to say is create tower at position, and then I say if I can create the tower at the position, then create the tower and push it back. And then this function can create tower at position, can just do its own thing. How I'd like to do this is I'll return true at the very end, and then what I'll do above it is add all, holy cow, add all the conditions where I'm not allowed to place a tower. And the producer has kindly told us this. So here we want to say, if I'm not on a brick, I can't place a tower. If I'm on top of another tower, I can't place a tower. And that's it. Those are actually the only requirements. So let's see if we can do this quickly. So physics already has a function here that says process collision. And what process collision does is it takes two entities and it actually moves them if they're colliding, which is not necessarily what we want to do. We want to do something very similar, but we just want to get back a Boolean that says if they are colliding. We only need to move entity 1, only need to move entity 2. Let's just think for one more moment. Okay, what I think I'm going to do, and this is a little bit ugly, but I'm going to write a new function called isColliding, which essentially does the exact same thing as process collision, except it's not actually going to move the items, but instead, if it would move the items, it'll just return true and say, which essentially lets us know that they were colliding. So I'm just going to copy that all. And this is probably where some people start to grimace inside. They're like, oh, look at all this copy and pasting. And we could do this so much more performant. But what we're really worried about right now, and what our producer cares about right now, is that we do this quickly, that we do it correctly, and that the end result is what people want to see on screen. And that's just the truth. So here we'll return true. We can remove this comment. We're doing something here, so we return true. Let's see this. We're moving here, so we return true. This returns true. This returns true. This returns true. One more. One more. One more. One more. Now, the only caveat here is that I don't know if this will work if you passed in two static objects. Okay, I've just taken some time to refresh myself on what all this function does because I was kind of concerned about the double static case. And what I've realized is this function makes an assumption throughout the whole thing, which is that entity 1 will never be static. So what I want to do here is add an assertion. So what I'm going to do at the top is I'm going to hash include C assert. And then down in my collision function, what I want to say is assert that entity 1 physics data dot type is not static. Entity physics data type static. Because if entity 1 is static, that is a problem. That is something that should never happen. So I'm also going to add that to process collision. And then if we actually do go up and look in the physics code, you'll see that the first thing that we do when we're processing physics is we check if the entity is dynamic, because what's the point of processing a static object? I agree how the code is written. It's just if we're going to make assumptions, we really should assert just so that all future code also abides by that assumption. We don't have to worry about it. Okay, so back to my can place tower at position. What I would like to do is I would like to take the tower template and I would like to check if it's colliding with any existing towers. So I need to iterate over all existing towers in towers, and I will say if you know what, the towers are static, so this is immediately going to assert. Actually, I suppose for the colliding case only, it is all right if the first entity is static because nothing actually moves. So even though this is entity 2 check returns false, this doesn't matter. So in fact, none of this matters. This will just always return true. This will return true. This will return true. This one's just going to be true. Yeah, okay. This makes more sense. This is cleaner. I know I just said I'm not going to clean up this code, and now I am cleaning up this code, and now these ones both return true. These both return true. This all returns true. Okay. Is colliding. Much simpler. Still correct. Okay, moving on. So for every tower, we'll say is colliding, and we'll pass in the tower, and we will pass in the tower template. And remember, the tower template is constantly kept up to date with where we want to place it. On every frame, we move the tower template to the mouse position. So we'll say can place tower at position. If it's colliding with any of these towers, then you cannot place it at the position. And then the next thing we want to do is check to make sure that it is colliding with, we want to make sure that it is colliding with an aesthetic tile, but the producer said that they really care about the brick tile specifically. So let's start by doing what they asked. So if I go to my tiles, I think the brick tile is just, oops, what's wrong here? For tower and towers, if tower, missing a paren there. I think that the brick tile is the first tile. Oh, and you can see right now, we can actually check that our towers won't let me place towers that are colliding with other towers already. That is working, which is cool. Okay, nice. Sorry, getting distracted. The first tile in the tile set is the brick one. So what we want to make sure is that we want to make sure that when we place a tile, it is colliding with the brick texture. Okay. So the next thing we want to do is we want to get path tiles. I think we have, or get tiles of type. There's a function called some kind of get tile function. What did I call it? Get list of tiles. Okay, we want to get a list of aesthetic tiles. And then, okay, get list of aesthetic tiles. So get list of tiles. How do I do it in other places? I say get list of tiles. So I'll get list of tiles. The tile type that I want to get, tile option, tile type, aesthetic. So I want to get all the aesthetic tiles, and then I want to iterate over all of the aesthetic tiles. And then what I want to do is keep track of is on a brick. If we are on a brick, I'll set that to true and break. And then after, I'll say if we're not on a brick, then return false. So we've got a tile, and I can check is colliding, but this will also be true when we're slightly off of the brick tile. So what I really want to do instead, well, it's not that bad. The first thing I want to do is I want to make sure that this tile is that brick texture. So I'll say if tile dot get, actually, how do the aesthetic tiles work? When we place down an aesthetic tile, do they just have, so they have this texture rect, and it has this XY tile option. What is the best way to keep track of this? I could check the texture rect directly. And in this case, it would be 0, 0, 16, 16. It's a little clunky to do that. Set texture rect. Is there any way to just get the sprite? Did I ever add a get sprite? Sprite. Get sprite? No. Let's add a get sprite. We'll return a constant sprite. And then I am just going to check the texture rec right now. So I'm going to say const sf sprite ref r, tile sprite is fine, is get sprite. Then I'm going to get the sprite's texture rect. And then I'm going to have this other texture rect up here. If I'm not on a brick, I'll say sf int rect, and it'll call brick rect. Holy cow. And it is 0, 0, 16, 16. And just to show you why, when we initialize the tiles, when y is 0 and x is 0, the texture rect will be 0, 0, 16, 16. And that's the first one, and that's our aesthetic tile. If I just open up the repo for this real quick and go into the images, you can see this tile map here, that first tile, that's the brick one at 0, 0. So we go back down. This is my brick rect. I've gotten the sprite from the tile. I've gotten the tile rect from the tile. And what I want to say is if tile rect doesn't equal brick rect, then continue, else check if they're colliding. If they are colliding, then it's on brick and we break. And if it's not, then we don't. So let's run this again. And this time we cannot place the player anywhere. If I add a red tile, I still cannot place the player there. But if I add a brick tile, I can now place him there as long as any part of this tile is touching it, which is really, really maybe not exactly what the producer wanted if we think about it. I think the true essence of should I be able to place this tile here means that it's fully encapsulated on the brick. So I'm not going to worry about that right now. I think that I'll just let the producer complain when he sees this. Oh, actually, I think a decent start would maybe to be, instead of letting it be any part of this, even if it was just the center must be touching it, I think it would look a little bit better. So I'm going to do that instead. So what I'm going to do when I'm checking is colliding. Instead of checking the tower template, what I'm going to do is I'm going to create a copy of the tower, and I'm going to call it copy of tower with radius of 1. And then I'll do the copy of tower with radius of 1, and I will get the physics data on it, and I will I thought I had a function to set this up. Oh, it's right here. You can just say set circle physics on the entity directly. And what I'm going to do is I'm just going to say dot set circle physics, and I'm going to add a radius of 1. And then we don't actually need to do this on every single loop. We can just do this once outside of the loop. And then we will compare the collision there with a tower of radius 1. And you might be saying, why are you doing this? Doesn't this seem all convoluted? But that's kind of the point I'm trying to drive home here, is that you can't get caught up on these perfect solutions. You really need to just get it done what works. And I understand that there's probably some disagreement there, and some people think that this should be prettier, and if it was all prettier, there'd be less error prone, and that is true. But I also think that there is a real tangible trade-off between time spent developing and how much progress you make on the game. And in addition, making a game is not like most other programs where you have a clear, distinguished goal and you just need to progress towards that goal, and once you hit it, you're done. You can very easily add something to a video game project, spend tons of time making it really pretty, the code, making it really performant and work well, and then you play with it in game and nobody enjoys it and it gets cut the next day. So because of that, I think that we need to strike a balance between beautiful software engineering and things that work. And this works, and I think this is pretty safe because everything is local and gets deleted. And yeah, so the next thing that we'd like to do, if we go back to the email, we're actually starting to get through these pretty quickly. We can only place the towers on bricks. They don't overlap with each other. But the thing that we don't have right now is the player doesn't know when it's going to be a valid or not placement. So what I would like to do is this can place tower position function. I think that this could be really powerful when we're just drawing the tower template. So when we go to draw play, you'll see here that we set the tower template at the mouse position, and then we just draw it. But what I would like to do instead is say, if I can place a tower at my mouse's position, then I would like to, and I actually started filling this in here. I would like to change my tower template's color to green, else I would like it to be red. And then we can just go implement set color real quick. So if I go to entity.h, we have all this stuff, and I'm just going to add a void set color. And what this does now is that whenever we're in play mode and we go to draw, it'll grab the mouse's position, it'll move the tower template to the mouse's position, then it'll check, can I place a tower at this position? If it can, it's going to tint the tower template green, else it's going to tint the tower template red, and then it'll draw it. And what this will let the player do is kind of know quickly if clicking the left mouse button will do anything or not. And this lets the player get very precise placement where they get just on the pixel where it's valid, so they can really squeeze everything out of the game. So if we look at this now, valid, and you can press it, and you'll see that right when we press it, it turns red because now there's a tower there, so you can't place over another tower. But we've introduced a bug, which is that all of the towers that we create are now green because that's the color it was when we copied the template. So let's go fix that real quick. When we handle play input, and we create a tower at position. We additionally want to set the color of that tower to SF color white. Holy cow, capital W, SF color white. And a white color just means don't mess with the color. So now if we go in here and we place towers down, you'll see that they're the regularly expected color. Very cool. So yeah, let's continue on to the next requirement. I think we've pretty much finished the tower placement one. The next thing that we'd like is that the towers should throw axes at the enemies. And then the towers should face the enemies as they throw the axes. And then we'd like the axes to spin. So we'll see about that one. Let's keep going on here. So in our game, in our update play, we need to update our towers. And so what I'm going to do is right now we kind of have all of the enemy code just sitting here out in the open, and then we do the physics at the end. But you can kind of see this is starting to become a runaway train. So what I'm going to do, instead of writing all the logic here, is I'm going to add a new function called update towers that'll update all of our tower logic. Instead of, just making update play some massive function. So these are going to be my play functions, or my play update functions. And these will be my level editor update functions. And then I will say update towers. And then I should be able to just go create that. Nice. Okay, so for each tower, for each entity tower in my towers, we need to do some stuff. So what do the towers need to do? They need to check if it's time to throw an axe. Then they need to find the nearest enemy. Then they need to create an axe and set its velocity. And then they need to reset their axe throwing timer. Okay, so check if it's time to throw an axe. So if we are a tower, and what you'll notice here is that entities can be anything right now. So they can be enemies, they can be players, or rather towers, they could be axes. And because of this, and because we haven't had any derived entity classes yet, we have some shared data that's not being used. So for instance, this path index is only used by enemies, and this float attack timer is only used by towers. And what I'll say is that I don't think our project is complex enough where it warrants separating this yet. So yeah, I don't have that much else to say about it besides thinking about separating this into derived classes right now, like having a tower class and an enemy class. I think that would probably take me like 30, 45 minutes of work. And there's really no point in doing that because I don't think I'll get much out of it besides being able to save a little bit of memory. So I wrote attack tower. I meant to type attack timer. And I would like this attack timer to be initialized to 1. So I'll say attack timer. I'll set it to 1. And then in game, what we'll do is we'll say tower.attack. Whoops. This is a private variable. So what we'll say is, well, we could make it public. This is another thing. Should this variable be public or private? I'm not sure, but I'm just going to make it public right now so I can keep working. So the attack timer, we reduce it by delta time as seconds. And then we'll say if if tower.mf attack timer, relax GitHub, is greater than 0, then just keep going. So we'll say here, we'll say we're not ready to attack yet. But if we get here, then we should find the closest enemy. So what we'll do is we'll say nearest enemy, and then what we'll need to do, we don't actually, no, that's fine. Yeah. So what we're going to do is we're going to iterate through all of our enemies. We're going to find the vector between our tower and the enemy. We'll get the distance of that. If the distance is less than the nearest distance, then we'll set the nearest distance to the distance to the enemy, and we'll set the nearest enemy to the enemy found in the list. If we didn't find a nearest enemy, then there's no one to attack, and we can just keep, we can just go to the next tower. Actually, we could probably just return now. No, we can't return because we need to keep decrementing the attack timer. Okay. But we get here, which means that there is an enemy. It is time to attack. So we need to create an axe and set its velocity. And what you'll notice is that we don't have anything for axe. So what I'd like to do is do something similar to what we did for the tower and the enemy, where we bring back this axe variable, but we'll call it axe template. And then we'll add in a list, not a board, a list of axes. Very cool. We'll scroll up here. We'll say axe template. It is going to be dynamic because the axe is going to move. Click axe template. Here's our axe texture. So we're going to set the texture to the axe texture. We're going to set the scale to 5. We'll set the origin to the middle of the axe texture. We'll set it as circle physics, so it's going to be just set up the exact same way that we did the tower template for the player. And then I think this is all good. Yes. Okay, I did think about this problem a little bit ahead of time. So there is going to be some weird stuff with the physics here, and I think we have a good way to solve it, but I'm not going to get ahead of myself. But what I will say right now is just that when a tower spawns an axe, the axe probably doesn't care if it's colliding with the tower or any other axes. It really should only care if it's colliding with an enemy. And we don't want to handle that by setting entities to ignore. We probably want to handle that by letting our physics data put itself into buckets. So for instance, we could have a projectiles bucket possibly, or we could have an enemies bucket and a towers bucket, something like that. And then we could say something along the lines of an axe is a projectile and projectiles ignore towers. So that would make it so the axe only looks for collision with something like an enemy. But anyways, let's keep going because that problem will surface regardless of what we do. So we're updating the towers. There is an enemy nearby. It's time to throw an axe. What we want to do is we say entity, new axe. We want to set the axe is, what is this? This would be A minus B is B to A, tower to enemy. I mean, maybe that's fine. What we want to do is we want to set the new axe's position to the tower's position, and then we want to set the axe's velocity towards the enemy at some speed. 500 seems really fast. And then the next thing that we want to do is we will set our attack timer back up to 1.0. Okay, cool. Now, some other things we need to do when we draw the play mode, we need to draw all of our axes. So we'll draw our enemies, and then we'll draw all of our axes. Then we'll draw our towers. I actually think we should draw our axes probably on top of everything, so I'm going to draw them very last. And then additionally, in our update physics, we need to go through our, I don't like the order of this stuff. I want it to be like this. We need to add all of our x's. Very cool. If should ignore other entity for physics. Yes. And then this is fine. Update physics, move, blah, blah, blah. The axes. Okay. Let's just see what it looks like, because there's going to be some things that we definitely need to change. So what I'm going to do is just start a very, very, very simple level, spawn, and here's my path. And then I'll put a guy here, and you'll see that they start just throwing the axes. Very cool. Very, very cool. Okay, so we are slowly progressing. A couple things to note here. 1, the axes do nothing when they hit the enemy. 2, the axes actually persist forever. So even though they're flying off the edge of the screen, over time, we're just going to have some absurd surplus of axes. Actually, I think our game's even already lagging quite a bit because all of the axes are checking all of their collision between all of the other axes, which is kind of insane. Okay, so let's carry on. Let us address one problem at a time. Let's make the axes disappear when they hit an enemy. So how we do collision right now is this. We go through all of the entities. We say, are you dynamic? Which an axe would be dynamic. And so would enemies for that case. And then we check for collisions. By calling process collision. And then here we not only check if there was collision, but we also resolve the collision and blah, blah, blah. So what I would like to do is any of these times where we move, it would really be nice to do almost both of these at once. No, I'm not going to get ahead of myself. So I think what I want to do is because they'll get moved and they'll process the collision at the same time. 1 second, I'm going to think about this. Okay. Back now, and I thought of what I would like to do for this. So the first thing I would like to do is add a flag system to our physics data. So I'm going to add an integer here, and I'm going to say my type, and an integer, and I'm going to say types to ignore. And then I'm going to add a new enum here, and I'm going to call it type. No. I'm going to call it layer. I'm going to say my layer, and then I'm going to say layers to ignore. And I will show you how I will do this. So, layer enemy will be 0. Tower, I'm sorry, enemy will be 1. Tower will be 2. And projectile will be 4. And what you'll notice here is what this looks like in binary is this, and this one looks like this, and this one looks like this. And what this is this is just a common implementation of a flag system where you take something like an integer and you let every single bit represent some piece of information. So, for instance, you can say, and let's add some helper functions here. So we'll say void set layer, and it's not actually going to take in a layer. What's going to take in is an integer. Set my layer to that, and then void set layers to ignore. I guess this could be an S also, because you could have plural layers. Okay. This is all good. Now we need to update our templates. So tower template, m tower template dot get physics data dot set layers, and I'm just going to have it as entity physics data layer tower. And towers are static, so we don't need to worry about setting anything to ignore because they don't collide with anything. Next, I need to set up the enemy. And the enemy's layer is enemy, and enemy template.get physics data. For the sake of showing people, no, actually I kind of like that the enemies collide with each other. So I'm going to do nothing for that. But for the axe template, I am going to say set layer to projectile, and then the axe template, get physics data, set layers to ignore. And I actually don't want towers to, I don't want axes to ever hit towers, but I also don't want them to ever hit projectiles. So I can just do a bitwise or here and say or projectiles. And then in our physics check, where we say should ignore entity for physics, we can do two things. We can check, is that entity in my strict list of entities to ignore for physics? Or we can check if, what was that going to fill in for me? Nothing. If entity dot get physics data dot has is in layer, and then we can say bool is in layer, and then we need to add int get layers to ignore, and then we should be able to do something like this. We should say if the entity is in layer, and then we pass in get layers to ignore, then we should ignore them. So, for instance, what is our physics data called? Physics data, yeah. That's what I typed, wasn't it? Very confused right now. Oh, whoops. Okay. So let's take in an integer. So this will say my layer, and that layer equals layer. And this is a bitwise and. So if layer 1 is set on here and I am layer 1, it'll equal the layer at the end. So actually, I would like to say is in any layer and return that this doesn't equal 0. Yes, because I'm going to get layers to ignore, and you get layers to ignore. We'll have 2 layers, and if it ends with a projectile, it won't be 0, and if it ends with a tower, it won't be 0. So both cases are good. Is in any layer. Okay. So now when we run the game, we should actually see the axes spawn directly on top of the towers because they're allowed to. But it doesn't quite look like it does. Let me check. I could probably kind of check this by putting towers on both sides. The axes are hitting the towers, actually. Okay, I just, excuse me. I just sorted out my first bug here, which is that this get physics data function was returning a copy of the physics data. So I was messing with a temporary, which is not great. What I really want to do is say get physics data non-const, return that. And now there should be a bunch of red in my game. Yep. And just to reiterate what my problem was, I was calling get physics data, and then I was setting things on that physics data, but that physics data was a copy of my physics data. It wasn't a reference to my real physics data. So the layer stuff that I added for physics was all being not set at all. So let's try this again. Set an end and a path and a start. We'll put some guys. Oh, I had a breakpoint set here and breakpoint set here while I was debugging. Put some guys here, and let's just see if, yep, now you see the axes are not colliding with the players, and the axes additionally are not colliding with each other. The axes are only hitting the enemies, which is very cool. Okay, and then I don't know how long it's been or what I said before, but just to go over this again, I added a layer system where I have a new enum. Each enum is 1 bit, and then I set that as a layer, and then additionally I have this option to say layers to ignore. And then when we do our physics check and we say should ignore entity, I check if the entity I'm comparing myself to, if they are in any of the layers that I'm choosing to ignore. So axes will ignore other projectiles and other towers, but they'll still hit enemies, etc. Okay. Then the next thing I would like to do is in my physics update, in my physics, or did I say update physics, bear with me. I'll say if the other entity isn't me, and if we shouldn't ignore it, which means we should process collision, I'll say if I'm colliding with them, then call the onCollision entered function. And so let me add, actually I'll do this. I'll say, are these pointers? Oh, yeah. Okay. I'll say entity on collision, and I'll pass in the other entity, and then I'll say other entity on collision with this entity. And then additionally, what I'm going to make sure is that these entities haven't already collided with each other, because we're going to be checking both of the entities in our physics update. So if 2 axes hit each other And for some reason, the first separation, or rather, it could happen that the first separation moves them and then the second axis updates and they hit again. So what we want to say is we want to just check if they have collided before. So we'll say if they're colliding, then call the on collision events, and then additionally add I could add entity to ignore. That would be one way to deal with this, but I'm not gonna do it. I'm gonna say add entity that I add entity collision, and this will add the other entity. And for the other entity, I want to add entity collision for this entity. And then before any of this starts, before I check the is colliding, I'm going to say, I'm going to check if has collided this update. I'm going to put a not in front of this. If I haven't collided this update and I'm colliding, then call this, and we'll check this other entity. And then additionally, when we iterate over all the entities, the first thing that I want to do when I get to a new entity is, or actually, you want to do this before you even go over the entities once, because if two entities collide, you'll set it on both of them. So the first thing I want to do is just say clear collisions. So now we have plenty of functions we need to go implement. So let's get to that. So on our physics data, let's look at this. We have a list of entities to ignore, but we're also going to have a list of entities that entities that I collided with already. And then we can say get physics data non-const clear collisions. And what we're going to do is we're going to add this function clear collisions, which clears this list that I just added of entities that I collided with already. Then we need to add a couple more here, and these are all going to live in non-const physics land. So I'm going to just put this in front of them. All right, the next one is going to be bool has collided this update, and it is going to take in a pointer, entity pointer other entity, and we just want to check if the entities we collided already contains it. If it does contain it, return true, because remember, if we have collided already this update, we don't want to call the on collision function because we don't want to have duplicates of that. And then finally, we need to say add entity collision, and we'll just add that entity to the things we've already collided with. And then, actually not on physics data, physics helps us know when collisions happen, but when physics collisions actually occur, that should probably live just on the entity itself. So we're going to add a new function out here called on collision, and this will take an entity ref to the other entity, which is all we need. So this is a lot of work just to get to the on collision part. And then what I think I would like to do is, if you remember, we need to set up the axe stuff. So, and enemies need health. There's lots of like fluffy requirements that we just haven't done yet. So what I'm going to do here is I'm going to say health, and for enemies, they need to have 10 health. So I'm going to add a set health function here for the enemy template. Enemy template. I'm going to say enemy template dot set health, and I'll set it to 10 because that is what our producer asked us to do. No, enemy should have 3 health. So I'll set that to 3. And then on collision, if the other entity is in any layer, if the other entity if the other entity is an enemy, we want to say if the other entity is an enemy, if we're a projectile, and we can do that by just saying getting our own physics data and saying is in any layer, and then we'll check the projectile layer. Whoops, this needs to be an if statement. If we're a projectile, okay, we can say this. This means a projectile hit an enemy. So what we want to do is we want to reduce the health of the enemy. So we'll say void, we could even call it like deal damage. That's probably fine. So we'll do the other entity dot deal damage. And remember that the axes want to deal 1 point of damage. And then there are some special things here. Special things to note. When an axe deals damage, it should disappear. And when an enemy reaches 0 health, it should also disappear. So one thing that I would like to do is be able to mark objects to be destroyed. So if you remember right now, in update play, really the only time we ever destroy an object is when, is when an enemy gets to the end of the tile, or gets to the close enough to the end tile. But additionally, I would like to delete objects in other places. So what I'm going to do is say check for deletion requests. And I'm going to add this as a play function, void check for deletion requests. And what this is going to do is it's going to iterate through all of our entities in the game, and it's going to check if they have asked to be deleted. So bool mb deletion requested, and of course things are not going to initially request to be deleted. So I'll say deletion requested is false. I really just botched this up, didn't I? That should be that, and that should be that. Should be a little prettier. Deletion requested should be false. We can also, well, let's not even worry about the health right now, because the health on towers and stuff like that, towers and axes, doesn't matter. So when we deal damage, we can say if our health is less than or equal to 0, then we want to be deleted, deletion requested. And if we are an axe and we've just hit an enemy and dealt damage, we also want to be deleted ourselves. And then in the game, what we want to do is iterate over all of the axes. We want to iterate over all of the enemies. And instead of doing whatever GitHub Copilot has put in there, we will say check if the deletion is requested. And if it is, then we'll delete it. So we'll say enemies dot deletion requested, then erase me, and we'll get the axe, and we have to say deletion requested, delete me. Cool. So now what should happen is the axes should hit the enemies. The axes should deal 1 damage. After 3 damage has been dealt, the enemy should request to be deleted. When we check for deletions, since the enemy is requested to be deleted, the enemy will be deleted, yada, yada. Okay. Whew. So we're making good progress. The last thing I would like to do right now is add a timer to the axes so they don't live forever. So I am going to do this. I'm going to say float mf axe timer. And this axe timer will be the time that an axe is allowed to travel in the air before we just request it to be deleted. So then in my update play, I am going to also update the axes. So if I go over to, oops, wrong one, update towers, I wanted to say update axes. Add that in here. We'll go through all of the axes. We'll reduce the axe timer. And then if the axe timer is less than or equal to 0, we will request deletion. So we'll go here and we'll say void request deletion. Okay. Let's see what this looks like so far. So we go into level editor mode. Put a start and an end and a path. Then we can put down some guys. And I don't know if we'll deal enough damage before they get to the end to destroy any of them. So let's add some more bricks so we can add more guys. Nice. Very cool. So this seems to be more or less working how I want it to. Let's go back to the email. The email guides us. Tower behavior. Tower should throw axes at the nearest enemy, and tower should face the enemy as they throw the axe. So that is one thing that we're not doing right now, is we're not facing the enemies that we're throwing at. So let's say update towers. We have found a nearest enemy. Rotate the tower to face the enemy. I think we already have, yeah. I don't think we have this though, angle between vectors. Okay, I've opened up this other HPP file that I wrote myself for another project, and I am going to just steal this angle function. It looks like it finds the angle relative to the down axis, which is what we want because all of our sprites face down to begin with. So an angle of 0 would point us directly down. So I'm going to copy paste this in. We'll see what all we need to add. I'm just going to get rid of this maybe unused thing because it's probably just going to confuse people. And then we need to add some of these constants that I have. So I'm going to go and steal those. I'm just going to steal all these constants because it does not hurt to have them. So here are all my math constants. And then what I can do, I might as well make this a capital A because in this project I've made all these math functions with capital letters. I'm just going to say angle. And I think it just takes in one value because it's by default the angle from the bottom. Okay. Once again, I am a goofball. I need to be able to get the sprite non-constant so I can call set rotation. Now, the only caveat here is that I have no clue if this is an angle or a degree or what's going to happen. So I'm just going to fire it up and we'll see where we end. Start, end, path. There's a guy. And it seems to work. Very cool. Thank goodness I already wrote this once, or else this would be a big pain in the butt. Okay. Might want to turn on like anti-aliasing or something. Rotating these sprites looks a little awful. Neat. Okay, we have that. There's also a bonus. Oh, here's me looking stuff up. There's also a bonus here that says we like the axes to spin as they fly through the air. We could do that. I don't think that would be too bad, actually. When we update the axes, we have to say axe.getSprite non-const dot rotate, and then it'll be some rotation speed. So const float axe rotation speed, and if it's multiplied by seconds, this will probably be the angle, rotate the object, current angle, set rotation. I'm assuming it's going to be radians or something, so I'm just going to set this to maybe 3 right now. Let's see what that looks like. So I have my things there. We'll have a start, an end, a path. Put some guys here. I'm not seeing the axe rotate at all. So is it just rotating really slowly, or is it not rotating? I think it might just be rotating really slowly. So let's try 360. Oops. Start, end, path. Oh, nice. Okay, so now our guy's face, and we have the bonus objective of the rotating axes. I think my producer is going to be really happy with this. Let's keep going. So we have the tower placement. We have the tower behavior. Here's some other stuff. We don't have anything for the player right now. So we need to have lives and gold. And it's not a specific requirement to see the lives and gold, but I have a feeling that even though it wasn't specified that they'd like to see the lives and gold, that the first question they're going to ask is, how much life and gold do I have? So I'm going to draw that on the screen as well. So let's go look at how we draw some other stuff on the screen. Like, how do we draw the game mode text on the screen? It looks like we just have some game mode text and we just say draw. And then where do we set it? Looks like the position is just set somewhere. Game mode text. So what I'm going to do here in the game is I'm going to add some new text, and I'm going to say player text. And then whenever we initialize the game mode text, I'm going to initialize the player text to something similar. I believe this is offset from the top, so that would be over 960 and down 100. And I probably want it to be something like over, so the screen width is 1920. So let's try maybe 1500 and see where that ends up being. Oh, duh. I'm sorry, you're not going to be able to see that anywhere unless I draw it. So when I go draw play, the last thing I would like to do is, well, yeah, let's draw it even after the tower template. So we'll go window.draw, and we'll draw the player text. Let's see what that looks like. Just says it right there. And then what we'll need to add here in the game is a couple variables for the player. I'm gonna put it down here. Gameplay variables. I'm gonna say int player health and player gold. And then we will initialize these both to 10. I think that's what the producer said. 10 gold, 10 lives. And then a tower should cost 3 gold. And every time an enemy reaches the end, you lose 1 life. Okay. Cool. So I think the other thing we could do is when we update the level editor mode, right now we're clearing the enemies. I think it also makes sense to probably set the player's health back to 10 and set the gold back to 10, just so we can quickly switch between level editor mode and play mode. And that also sort of makes level editor mode be a way that we can reset the game once you lose the game. And then when we draw the play mode, we don't want to draw the text just whatever it says. We want to say set text and this might be fine. This should say player health and player gold. You see them right there. And then let's look at some other stuff. When we handle input, or I'm sorry, when we handle play input, we want to say create tower at position. But before we do that, we need to say, there's a couple things we want to do here. Let's see here. So we say create tower at position, but when we left click, we shouldn't actually do anything if we don't have enough money. So we should say is if mi player gold is, this is probably an okay way to do it. So if, actually what I'm gonna say is if player gold is greater than or equal to 3, if create tower at position, subtract the gold. And then the thing we need to change here is that create tower at position, instead of being a void function, we're going to change this to a bool function. And if we do create the tower at the position, we'll return true. And if we don't create the tower at the position, we'll return false. So let's go update the tower at position, update the declaration of it. And it's too many C's. So create tower at position. We'll subtract the gold. Additionally, whenever an enemy dies, we will add a gold. So I will do this. I think probably handle check deletion. Where is it? Deletion requests. So right now, when an enemy reaches the end, they just delete themselves immediately. So the only time an enemy would ever be requesting to delete itself here is if the player defeated the enemy. So it's probably safe for now to just add 1 gold if the player ever gets to this spot. And then additionally, when we're updating play, and we update all the enemies, if an enemy gets to the very end right here, then we'll say player health is -1. And then in update play, if we just go to the very beginning of update play, we update the towers, we update the axes, we update the physics, and we check for deletion requests. We can say if player health is less than or equal to 0, then we just return here. And what this means is that towers will stop being updated, axes will stop being updated, spawn tiles will stop being checked to spawn enemies, enemies will stop moving, physics won't be checked, deletion requests won't be checked. And then when we say draw play, what we can say here is that if the player's health is less than or equal to 0, then we can draw the game over text, which means that we also need some game over text. So let's go here. We'll say SF text and game over text. And this is another thing, like the producer didn't explicitly ask, hey, could we have game over text? Could we have whatever? But you shouldn't need, that's, I'm not going to say you shouldn't need it to be said, but some things just won't logically work unless you do them. So if the player reaches 0 health and nothing appears on the screen to let them know, everybody's just going to be confused. So saying game over is probably a good thing to do. And then let's just start this up. And what I want to check first is just make a spawn and end, and this should be enough. My NVIDIA thing is in the way. Go away. You see the enemy spawn 0 now. Uh-oh. Okay. It's not saying game over. Why is it not saying game over? Let's go check. Game over text. Duh. Draw play. I forgot to actually put, I wrote a comment that said draw game over text, but I did not actually draw the game over text. So that was very silly of me. So let's try this one more time. And I'll space it out a bit this time so we can actually see the enemies to make sure that they stop moving once the player's health reaches 0. Oh. There you go. It says game over. And the text is not centered, but at least we can see it says game over. And if I click level editor mode and click out, it just goes right back to the game. Nice. Let's look at, or actually we didn't check to make sure that the towers are working how we want them to. So let's make sure that that actually works. So we'll say spawn here, end here, path here. Yeah. And then these stink. So the towers literally stink. You can't beat the game, but that's okay. That's not really the point. Oh, and that's the other thing. So when we restart, we're not clearing the towers. So we should definitely clear the towers. Let's add that real quick. So when we're updating the level editor mode, we want to clear the enemies. We want to clear the axes, not the axe textures. Axes.clear. And then we want to clear the towers. Then let's look if we have any more requirements we missed. So we have our tower placement. They don't overlap. You can see a preview. And once again, that preview is just that like red, green. The towers throw axes. The axes spin. The towers face them. The player starts with 10 gold and 10 lives. The player loses 1 life every time it reaches the end. The player reaches, the game ends. Tower should cost 3 gold to purchase. Axes should deal 1 point of damage and disappear once they're hit. Axes should persist once they hit. I'm not going to do this bonus one right now. Please feel free to do it at home if you want to. It's very fun. Axes should have, enemies should have 3 health and should disappear once their health reaches 0. When an axe hits an enemy, it should knock the enemy back. We did not do this one. Okay. And enemies should die. Player gains 1 gold. Enemies should spawn faster over time. Okay, so I think there's just 2 things we haven't done yet, which is that enemies should spawn faster over time. And when an axe hits an enemy, it should knock the enemy back. So I think the first one's going to be more interesting. First one in the list there, the knocking the enemy back. So if we go look at our update physics, the first thing that we do when we update the physics is we move it by the velocity times this delta time. But additionally, what I think we'll need to do is move it by like an impulse. So the enemy will still move, but we'll allow some impulse to just shove it back in some direction. And this could get a little clunky, but I'm totally willing to see how it plays out because it sounds kind of cool. So what I'm going to add here, and it's not a true impulse, I get that, but that's not really the point. Okay. So what I'm going to do here is add this SF vector to impulse. And then the impulse, actually, we probably should have a constructor. Physics data. Impulse. Okay. And then what we'll do here is that when we move this, we will move it with the velocity times time plus entity get physics data dot impulse. And the impulse is not dependent on time. So the impulse is just a flat out movement. And then once we're done doing that, I want to clear the impulse. So what I'm going to do is say get physics data non-const dot clear impulse. And then in the physics stuff, I'm going to add a void clear impulse function that just sets impulse back to 0. And then I'm going to have a void add impulse function, which just adds on to the current impulse. And then when we update play, or rather, when we update the axes, let's go to that real quick. Or no, it actually happens in the on collision. Ooh, that kind of makes things tricky, doesn't it? Because it'll collide and add the impulse. No, actually, maybe that's fine. Maybe that's fine. Okay. Yeah, it's a little weird because the impulse might be processed the next update, but I don't actually think that'll result in any tangible difference. Okay, so let's do that. So find the direction from projectile to the enemy. So we find the direction, and then we're going to normalize it. And then we're going to take the enemy, and we are going to get physics data non-const, and we're going to add an impulse. And let's just start off with direction. So remember, this is literally how much it's going to move. I think let's start off with like 80. That is the full. That's pretty far, to be honest. And then what are we missing here? On collision. Okay. I think it's probably about time that we just move this into the implementation file anyways, or rather the source file. So on collision, this will be in here. And normally you'd put like all of your functions in a CPP file. There's really no point in having all these in the header. They're just gonna bloat up your program and eventually just destroy your compile times. But we're not worried about that right now because the producer did not tell us to worry about that. Okay, we'll add our math include there. And then let's see how this plays. Ooh, what the hey, bro? Whoops, I forgot to make all of my math helpers static. So I just changed those to static real quick. Now I'm back in game, and I have just added in the ability for the axes to knock back the enemies. And this is looking like it's working really well. It's maybe a bit jerky. But that's okay. And then the next thing that we need to do, and our final requirement, is that over time, the rate that the enemies spawn at should increase. And I know that it's not specifically asked for here, but if we're going to increase the spawn timers, the enemy should probably move faster also. So what I'm going to do is I'm just going to add a float called time in play mode. I'm going to initialize this float to 0. And whenever I'm in level editor mode, so when we do update level editor mode, I'm going to say time in play mode equals 0. So it kind of resets it every time we go to level editor mode. And then when we update play, I suppose it doesn't hurt to just say plus equals there. Even if our health is 0, technically we're still in play mode. And then for enemies, So this is where we spawn enemies. So what I'll do here is I'll say int f spawn timer multiplier equals time in play mode divided by 10. So what'll this give me? Every 10 seconds, this number will go up by 1. Okay. Well, actually, let's do this. Every 5 seconds, this number will go up by 1. And then what I want to do is say float spawn rate will be 1.0 plus spawn timer multiplier. Remember, this goes up by 1 every 5 seconds. So after 1 minute, this will be at 12. So what I want to do is divide it by 10, or divide it by 10. And then instead of just adding on to this, I'm going to multiply it by this spawn rate. What this means is that after 1 minute, the spawn rate will be 2.2. So it'll be like 120% faster. And then we could just see how that works out. And what we should be able to do now is that if we just have that same simple setup that we had before, where it just spawned and went to the end, and we kind of were just destroying this level, eventually we should lose because things will be spawning fast enough. So let's see how this plays out. And it is a little ADHD how aggressively, oh, they're definitely going fast enough now. Really close. Yep. And we're losing. Cool. Yeah, I think I'm happy with this. Okay. Hey everyone, I just finished up assignment 1. And so I'd like to just quickly showcase where I ended so that you can get an idea of where we're going throughout this video. So if I fire up the game right now, we can go into level editor mode and set down some of these brick tiles. And then we'll put on a spawn tile here, an end tile here, and a path in between. And then you'll see that we can place towers down, and we have a little indicator that lets us know if placing the tower is going to be successful or not. So when it's green, it means that placing the tower will be successful. When it's red, it means it'll be non-successful. We have the player health and the player's gold in the top right hand. Every time we kill an enemy, we get 1 more gold. Every time an enemy reaches the end, we lose 1 life. The enemies spawn faster over time. So even though I'm killing it right now, the enemies will eventually win. The towers, which are just these little humanoids, face the enemy that they're throwing an axe at. The axe spins as it goes through the air. And then what were the other requirements? Let me go take a little peek. Oh yeah, so the gold stuff. So when we kill an enemy, we get 1 gold. It costs 3 gold to buy a tower. And then additionally, the rate at which enemies spawns ramps up over time. So I'm just going to be patient for a second and wait for it to ramp up. I have it ramping up at about 120% every minute. And keep in mind that the goal with this assignment is not to finish the game and make it balanced. The goal is to just do whatever the producer says, essentially. So 1 more in there, and then bang, game over. You get a little game over thing. The whole game freezes. And to reset, you would go into level editor mode and back into the play mode. And yeah, so that's where I ended up after assignment 1. So yeah, thanks so much for stopping by, and don't forget to like and subscribe and leave a comment if you want to. Take care.